Okay, this is web assigned 6A, number 17, and the problem read, a disk of 7.9 centimeters in radius rotates at a constant rate of 1,190 RPM on that rotates on the central axis. And part A asks to find the angular speed, and so First I'll draw the picture of the disk. So this is the radius, and the radius is 7.9 centimeters. And what I'm going to do, I'm just going to convert that right to meters right away. So 0.79 meters. You just divide by 100 to get that. So and then part A asks to find the angular speed, and the thing is, it gives you the angular speed, but it wants it in radians per second, but it gives you it in revolutions per minute, so you have to convert it. So you have to convert 1,190 revs per minute to rads per second. So one revolution. Here, I'll write this down here. One revolution is equal to 2 pi radians. That's a conversion factor, so you multiply by 2 pi radians, and that cancels out the revs. And then to get the minutes out, you have to multiply by 1 over 60, because there's 60 seconds in 1 minute. So, and then that gets you 124.6 radians per second. And this is your angular velocity. So, now part B has to determine the tangential speed at a point 2.94 centimeters from its center. So, and it asks for it in meters per second. So, determine the tangential speed. The tangential speed is basically the linear speed at that point. So what we're gonna do here is tangential velocity is equal to r times angular angular velocity. And so we get r. Let's convert the 2.94 centimeters into meters. So you just divide by 100. You get this. So stick that in for r. Meters times 124.6 rads per second. And then this will give you your tangential velocity at that r. And this was 3.66 meters per second. So where some people mess up is they'll put in the wrong r, so you'll get a different value if you put in the wrong r, or if you don't convert it. And that was a big thing with this problem, is that the conversion, there are a lot of conversions you have to do, so you have to be careful when converting your numbers. So part C asks to determine the radial acceleration of a point at the rim. So the rim would be the very edge, which we know from here. What the heck? Oh my god. We know from here is 7.9 centimeters away, so that's the radius, but we convert that to meters, and we already did, so then we know that radial acceleration is also known as centripetal acceleration, because it causes something to turn in a circular motion, and the acceleration is aimed towards the center, hence the name centripetal. So centripetal acceleration is equal to the tangential velocity over r. And this is also, so we can play around with this, this is also equal. So we know that tangential velocity is equal to WR, or RW, whatever, or RW, how we did up there in part B, and that was being squared. So if we square that, the r's cancel out, so you're left with rw squared is equal to the centripetal acceleration. So, and we knew, so instead of you can do this problem, I think, with by calculating a tangential velocity like at the rim and then plugging that in, or you can do it this way. I just did it this way, so because I thought it was easier. So this gets you r. Oh, and it asks for the centripetal acceleration in kilometers per second squared. So you have to convert. So after we convert r to r, we get 0.000079 times our angular speed that we found in part A that we converted to. We just plug in there, and then that gets us 1.23 kilometers per second squared for our centripetal acceleration. And then the final part as to determine the total distance a point on the rim moves in 1.9 seconds. So we know that. So for this one, we had to basically determine the tangential velocity of a point at the rim. So I guess we could have done that in the earlier part, but I did it a different way. So I guess we just have to do it now. So tangential velocity is equal to r times w. And be careful. So some people don't know that you have to be careful not to use this tangential velocity because this is the wrong one. Because it's not the same r. This one asks for the r 2.94 centimeters away, but this one you need the r that was from the original problem, which was 7.9 centimeters away. So you have to convert that to meters, and we already did that. 0.079 meters times 124.6 or rads per second. And that gets you tangential velocity of 9.84 meters per second. And now we can do the tangential velocity is equal to the displacement over time. And we know our tangential velocity, which is we just solved for it, 9.84 displacement or distance traveled over 1.9 seconds. Multiply 1.9 times seconds times 9.84 meters per second, and we get that the total distance traveled is 18.7 meters. So basically, the thing to watch out for in this is the conversions, because you had to convert in like every step. I think you had to convert something. So be careful when converting. Be careful with r and which like distance you use from the center, because as you know, like the angular speed, I learned in this problem that the angular speed is the same on every point. The angular speed would be the same, but there's a different tangential velocity at each point, and the tangential velocity depends on the r, like the radius, like the distance away. So that's what I learned, and then that's what you also have to be careful about. So